Good morning. I am Dr. Sathya, working as an assistant professor, Department of Chemistry, SNS College of Engineering. Today we are going to discuss about Teflon. Teflon is most important polymeric material. The Teflon is other name is called it polytetrafluoroethylene. So Teflon is a synthetic fluoropolymer made up of tetrafluoroethylene monomer. The chemical name of Teflon is poly1122 tetrafluoroethylene. It's a thermoplastic polymer. Teflon is the chemical formula C2F4. The Teflon formula shows the repeating on the number of C2F4 units. The Teflon was first discovered in 1938 by Roy Plunkett, an American chemist. So, who was working with EI. Some time of the World War, it was used as a corrosion-resistant coating. After a war in 1916, DuPont released the first non-stick cookware coated with the Teflon. So nowadays in day-to-day life, we are used in Teflon coated cookware in every product for used as a non-stick. So the synthetic fluoropolymer is a commonly brand name of PTFE based composition as Teflon. So the FTPE was accidentally discovered by Roy Plunkett J. This is the Teflon structure. So in figures we seen in non-stick cookware. So non-stick cookware is contains a high molecular weight polymer. It's consisting of wholly of carbon and fluorine. So it's a hydrophobic, neither water or non-watering substance wet FTPFE. You have one of the lowest coefficient of friction of any salt. It's a white solid of compound at the room temperature. It's a density about 2020 kilogram. It's a melting point around is 600 Kelvin. It's a chemical resistance compounds. The only chemicals that can affect the compounds are alkali metals. So it can alkali metals only the affect the Teflon compound. So it's good resistance towards the heat and low temperature. So this is the monomer of Teflon. So the monomer Teflon is combined together to form a large polymeric chain. So the green colored balls, it's called the fluorine atom. So the number of fluorine atom in the structure of Teflon and polyethylene, it's looking like same. But the only difference is hydrogen and fluorine. Here the instead of hydrogen, here we used fluorine element. It's produced by pre-radical polymerization of tetrafluoroethylene. The net equation is CF2 in large number of molecules. So it's denoted as N. So the thermoplastic polymer, which is a white solid at room temperature, it shows a good resistance and low water absorption capability. It's anti-adhesion ability due to which used as a non-stick kitchen vessels. It's a good flexibility at room temperature in 194 Kelvin. It's again it properties from aggregate effect of carbon fluorobonds. So the only chemicals known affect the carbon fluorobonds and highly reactive materials like alkali metals we discussed in previous slide and at the high temperature. Such metals of alkali metals like aluminum, magnesium and fluorinating agents like xenon difluoride and cobalt-3 fluoride. The temperatures above 650 to 700 degrees Celsius, PTFE undergoes the depolymerization. So the processing of Teflon can be difficult and very expensive because it's high melting temperature. So the production is very tough. It's used from the free radical mechanisms. It's sulfate catalyst used in this with high pressure heating. During the reaction of production of Teflon, the polymer tetrafluoroethylene decomposes into the tetrafluoromethane and carbon atom. So even when molten, PTFE does not flow due to the extremely high melting viscosity. So the viscosity of melting point can be decreased by inclusion of small amount of co-monomers such as perfluoro and hexafluoropropylene. So these cause otherwise perfectly linear PTFE chain to become branched and reducing the crystallinity. So some PTFE parts are made by cold molding and form of the compression molding. So here the fine powdered FTP is forced into the mold under the high temperature. The compression molding is the placed the Teflon polymeric material and pressure the high pressure. After the setting period, the lasting with minutes to days, the mold heated at the 360 to 380 degrees Celsius, allowing the fine particles to the fuse into the single mass. So the applications of Teflon is over the other compounds polymers are listed here. The Teflons is the most efficient than most of the other polymers such as nylon and acetal. So the polytetrafluoroethylene is the Teflon is the thermally most stable even at very high temperature. Its chemical properties make it an ideal material for various real world applications like electrical appliance, manufacturing and even the textile industry, as it's also used in the production of many clothing items. So in cookware, the non-stick property of Teflon has been used in the manufacturing of cookware ever since of discovery of the material. Its extremely low frictional properties and high resistance have made Teflon cookware it's very popular. So it's also used in machine parts. It's extremely low friction